All right, today we are doing day 2 of simplifying radicals. So we're just continuing on what we were talking about yesterday. But today we are going to have problems that involve division. For our warm-up, it's just what we had going on yesterday. So you can either do these using a factor tree or by identifying perfect squared divisors. What do we want to do? Factor tree works. What can we split 24 into? 2 and 12 is one option. Which one of those can keep going? 12 breaks into 3 and 4 works for me. Which one of those can keep going? 4 breaks into 2 and 2. After we make our factor tree, what are we looking for? Pairs of numbers. What do we find a pair of? A pair of 2s. Any other pairs? No. So what's alone? The 2 and the 3. What about all these other numbers? Cross them off. We're not going to use any of these other numbers. Only the ones at the very bottoms of our tree. So I've got my radical. What am I writing outside my radical? 2. Just 1, 2? Yes, for every pair, we only write one of those numbers outside. What about what's inside? 2 and a 3. What's happening to those? They're getting multiplied. So our final answer is? Good. 2 square root 6. Questions, concerns? Okay. On number 2, we've got a slightly larger number. It's not on our pink factor sheet, but it is an even number. So what could I divide it by to make it smaller? A 2. So if you're never sure quite where to start, you can always start by dividing by 2. And what would we have left? 81. Good. What could I break 81 into? We could use 3 and 27, or we could use 9 and 9. Why do I like 9 and 9? It's a pair. We can stop. If you wanted to keep going and get all your 3s, that's fine. But if you have a pair, you can stop and just circle that pair and not break them down anymore. If you keep going and get a bunch of 3s, that's fine. You're just later going to have to multiply a couple 3s back together to make a 9 anyway. Okay? So we can stop our tree there. What's our answer going to look like? 9 square root 2. All right, our note for today. When simplifying fractions with radicals, only simplify the numbers outside the radical. If we've got a fraction, we cannot simplify with the number under the radical or inside the radical, only outside. So example 1, we have 4 radical 3 over 12. So if we are looking at our denominator, there's no radical, it's just a number. So in the numerator, which number is outside the radical? The 4. So that means that when we go to simplify this, the 4 and the 12 can get simplified or reduced, but we cannot touch that 3 underneath the radical. Okay, it's like you got a barricade around it. You cannot simplify with that 3, only with the 4 because it's outside. So if we simplify 4 over 12 as a fraction, what's the 4 going to become? I heard somebody say it. A 1. What's the 12 going to become? A 3. And what else do you think we're going to have? The square root 3 is going to go where? by the 1. The square root 3 is not moving, it's not changing. That's it. If you didn't write the 1 in the front, it would still be correct. It's kind of like 1x and x being the same thing. You could write it as just square root of 3 over 3. And now I know that it might be tempting to cancel these 3's out, but we cannot do that because this one has a radical around it. It acts like a barrier. It blocks it from getting canceled or reduced. On number 2, what numbers can I look at to simplify? The 10 and the 25. I cannot think about that 5 because it's underneath the radical. So I set up my fraction bar. What factor are we going to reduce by? 5. 10 divided by 5 is 2. 25 divided by 5 is 5. And what do I have to remember is still part of my answer? The radical 5, which stays in the top. All there is to it. Pretty easy so far?
Yeah.
It's just like simplifying fractions from back in junior high or middle school. They just also have those radicals on them. Again, I'll keep repeating myself. These 5's cannot simplify with each other because one of them is blocked by a radical. Okay, let's move on. Couple things are different about example 3. Anybody notice anything different about it? Natalie?
The bigger numbers on top.
We've got a bigger number on top instead of in the denominator. Kian? Good. 5 and 2 don't have any common factors. So initially we might think there's not a whole lot that we could do with this. However, our number under our radical is not a prime number this time, which means we can simplify just this radical piece. So for right now, this is part of showing my work, I'm going to rewrite the 5 and the 2. I'm going to leave a little bit of space here in case there's something else that's going to come outside my radical. And I'm going to, off to the side, break down the square root of 20 so that we can see what it simplifies to be, just like we did yesterday. Does that make sense? Okay, the last 2 problems didn't have numbers that could be broken down, but 20 can break into what? 2 and 10. 10 breaks into 2 and 5. What is important to us here? The pair of 2's. And what's alone? Okay, so when I jump back over here to start filling in more of my answer, what goes outside by the 5? A 2. Remember, when we pull something out, we're multiplying it to that. And what stays inside? The 5. Questions about how I did that or why I did that? Okay. Now, the next step, you've got 2 options. What's one thing we think we want to do? Kian? That is one option. So one option is to multiply the 5 times the 2, and what do we get? 10 root 5 all over 2, and then what would we simplify? 10 and 2, what does the 10 become? A 5. And what does the 2 become? A 1, which you do not have to put it over 1, but it's okay if you want to. Does anybody see, if we go back up here, what else I could have done at this step? Cancel what? Cancel out the 2's. If you have a factor that's in common in the numerator and the denominator, they can go ahead and cancel each other out to reduce, and we're still left with the same answer. So we're still left with 5 square root of 5 either way. You can put it over the 1 or you can just leave it plain. Either one is fine with me. On this one, is there any canceling or reducing I can do right away? No, there is not. So I'm just going to set up kind of a shell of my next step. I'll put my 2 right by my radical this time and leave space in the front. And off to the side, I need to simplify the square root of 27. What is 27 breaking into? 3 and 9. Which one keeps going? 9 breaks into 3 and 3. What is important to me here? Pair of 3s. What's alone? The other 3. Okay, we should be getting really quick at that step of simplifying that radical. What's coming outside my radical? What's staying inside my radical? What do we want to do now? We can multiply. That's what you want to do. Or we can cancel out the 3's. Now, if I cancel out 3's, which 3's do we mean? The one in the very front and the one in the bottom. Why can I not touch the 3 back here? It's underneath the radical. It's getting the square root sign. Okay, so we can only do things with stuff outside of the radicals. If you want to multiply the 3 times 2 and get a 6 and then simplify later, you can. Or those 3's can just cancel each other out. That's usually the quicker way. And what are we left with? 2 square root 3. Again, on this one, you could put it over 1 if you want to, but you do not have to. Questions, concerns? Feel like we're getting this? All right, why don't you try number 5? It's very similar to the last couple that we've been doing. The only difference is that it does not have a number out in front to begin with. But our first step is still going to be to simplify the radical and then see if there's anything we can cancel out or reduce later on. So I'll still set up a fraction with 12 in the denominator and a square root symbol, leaving a blank space in the front and a blank space under my radical that I'll fill in after I simplify the square root of 90. See what you can do on your own, and we'll go over it together in just a minute. All right, if you're still working on this, that's fine. We're just going to keep it moving. On the square root of 90, what did we break 90 into? I like 9 and 10. What do we break 9 into? 3 and 3. What about 10? What do we like here? A pair of 3's. What's alone? Okay, so when I go to fill in over here, what's going outside? 3. What's going inside? 2 and 5, or I could go ahead and make that a 10. 2 times 5 is 10. If you need to do it one step at a time, that's fine. But I am confident in most of your ability to multiply 2 and 5 back together right away. Okay, what numbers are we looking at to simplify now? The 3 and the 12. So we got to pull from the numbers outside of radicals to simplify. What are we going to divide both 3 and 12 by? A 3. 3 divided by 3 is a 1. 12 divided by 3. And what else is part of our answer? The square root of 10. Now again, that 1 out in front is not entirely necessary. So if you were to see it written as square root 10 divided by 4, that's also okay. Those are the same thing. Questions before we move on to number 6? Okay, we've got 6, and then on the back we're going to make it just a little more interesting. Anybody start breaking down 256? 2 and what? 128. Okay, 128 breaks into 264. 64 could break into 8 and 8. Why do we like 8 and 8? It's a pair, which means we can stop. That makes it a little bit shorter. If you keep going, you're just going to get a whole bunch of 2s and end up having to multiply them back together. So if you recognize your perfect square numbers, it could help you break it just into a pair so that you're able to stop. What else do we see here? A pair of 2s over here. So is there anything alone? No. So when I come over here, I put my 15 in the bottom. If I'd set it up with my radical, that's fine. What's going outside the radical? 2 and an 8, and they are getting multiplied. Is there anything to go under my radical? No. So what happens to it? It what? Is there anything to put under it? No. So what did I say happens to it if there's nothing to go under it? If I go to write my next step, what do you think I'm going to write? 16 over 15. Do I write a radical at all? No. If there's nothing to go underneath it, it just goes away. If there is nothing to go under the radical, it goes away. Now I have to decide if I can simplify 16 over 15. Do they have any common divisors? Can 5 go into 16? Nope. No, there's nothing that we could divide both of those by, so that's it. It's possible you'll have fractions that can't simplify, and that's fine. Questions, concerns? Ready for the back? Some of us are, some of us are not. Okay, a friendly reminder. Only simplify the numbers outside the radical. Only simplify the numbers outside the radical. With the following problems, all 3 numbers outside the radical must be divided by the same factor in order to be simplified. These are the heart numbers. That is not a mathematical term. That is just something that we use to remind ourselves that we have to use all 3 numbers. So in this class and also in future math classes here, you might hear teachers refer to these as the heart numbers. You'll see why in just a moment. So real quick before we jump too far into the math of this problem. When they're talking about numbers outside of the radical, on number 7, what numbers are outside of the radical? Natalie? 3 plus 6. What number is also outside of a radical? 15. So they call these the heart numbers because you can kind of draw a little heart around them. Mine's not a very pretty heart. I think it works a little better on 8. The spacing's a little bit better. You can kind of draw a little heart around those numbers. All the numbers that are outside of radicals. Those are the ones that have to be divisible by a common factor in order to simplify. Not just 1 or 2 of them, but all 3 of them. Does that make sense? They've all got to be divisible by the same thing. So what could we divide all of our heart numbers by on number 7? A 3. If I divide 3 by 3, what do I get? A 1. Plus sign stays there. 6 divided by 3 is 2. Over 15 divided by 3 is 5. But what did I forget to write? My radical 2 has to stay back here. It's got to stay. It's not going to change. Another important thing that we need to know is that we cannot add this 1 and 2 together. Don't do it. This is it. This is our answer. I know it looks a little funny, but that's all there is to it. Okay, we cannot add the 1 and 2 together because the 2 has the radical 2 after it. Those radicals prevent us from doing a lot of stuff. Questions about 7? Okay, let's move on to number 8. We already kind of made a little heart around those heart numbers. What are all 3 of those numbers divisible by? A 2. 10 divided by 2 is 5. 2 divided by 2 is 1. What's going with the 1? The square root of 6. And then 8 divided by 2 is 4. Notice I did not divide the 6 by a 2 when I did all of that. Why not? It's under a radical. Can't touch it. Gotta leave it alone. And that's it. Again, do not add this 5 and 1 together. The 1's stuck with a root 6, so it cannot get added to that 5. Questions, concerns? Nothing that we're doing today is necessarily hard. It's just learning the rules, what we are and are not allowed to do. All right, take a minute to try 9 and 10. If you want to, right away, just go ahead. Make a little heart around your heart numbers, so that you remember only to look at those when you're trying to simplify. On number 9, what was our divisor? 5, good. Negative 20 divided by 5 is negative 4. Plus 5 divided by 5? 1. It has to stick with the square root of 2. Good. The denominator becomes a 5. I know I keep repeating myself, but I fear that I might have a student do it anyway. Do not combine these two numbers, the negative 4 and the 1. That one's stuck with a radical 2, so it cannot get combined with that negative 4. On number 10, what did we use as our divisor? 4, good. I thought some people might be tempted to say 2, which is correct, but it's not the greatest common factor or greatest common divisor. So we have to make sure we're using the biggest one. Otherwise, we're going to have to simplify again after. So if we use 4, that will get us straight to our answer. 24 divided by 4. 6. Good. 4 divided by 4. 1 is stuck with the square root of 6. 36 divided by 6. Sorry, divided by 4 is 9. Misspoke there. Questions, concerns? You getting the hang of these?
Yeah.
Good. Let's throw it all together. So on these last 4, we have to make sure that our radical is simplified before we start trying to deal with our heart numbers. So one other thing I want to point out before we start simplifying that radical, what number is currently sitting right in front of the radical? A 1. So if I were to make my heart numbers right now at the very beginning, is there anything that I could simplify them by? No. Okay, so we have to remember that even if there's not a number written in front of the radical, there is a 1 there. Okay, so the way it is right now, there's nothing we could simplify except to simplify the square root of 24. What do we want to break 24 into? 2 and what? Sure, 2 and 12. 12 breaks into 2 and 6. 6 breaks into 2 and 3. What am I going to circle? A pair of 2s. What's alone? 2 and a 3. So when I go to rewrite this initially, I have a 2 plus out in the very front. That 2 plus did not change. Now when I go to the radical part, what's coming outside my radical? Outside? A 2 from the pair, and what's going inside? The 6, because we multiply the 2 and the 3 back together. Remember, the lonely ones, the ones that didn't have a friend or a pair, have to stay inside the radical. They don't have friends, they can't go outside. All right, what's in my denominator still? A 4. So now when I look at my heart numbers, can I simplify all 3 of those by the same factor? Yes, what is that factor? A 2. 2 divided by 2 is 1. Another 2 divided by 2 is also a 1. Stuck with the square root of 6. Good. All divided by 2. 4 divided by 2 is 2. So this is putting together all those things that we've talked about. Simplifying radicals. Also simplifying radicals with fractions, the heart numbers, all at the same time. Ready to move on? Okay. Now, just as a friendly reminder, a 1 belongs in front of the radical right now if there's not a number written there. So with our heart numbers right now, we cannot simplify them. So what are we going to do? Simplify the square root of 45. What do we want to break it into? 5 and 9. 9 breaks into 3 and 3. What am I circling? Pair of 3s. What's alone? The 5. So when I come back over here to rewrite this, what's staying out in front? The negative 9 plus is not changing. We only dealt with the square root of 45. What's it turning into? Plus 3. What else? Square root of 5. Good. My denominator? Still a 3 for right now. Can make my pretty little heart around those numbers. Can those all be divided by the same number? Yes, what number? A 3. Negative 9 divided by 3. Negative 3. Some of your voices are so soft I can barely hear them. 3 divided by 3 is a 1, so plus 1 stuck to the square root of 5, all divided by 1. So if you don't want to put the over 1, you don't have to. This would be the same as just negative 3 plus square root of 5. We don't even really need the 1 in front of the radical. It's just a nice reminder. But either way you write it, this first way that we have it is fine. If you want to go this way, that's probably what you would see in a textbook. It's That's also fine. They mean the same exact thing. Questions, concerns?
No.
Okay. Let's see. 13 is a little bit different. There's two ways you could go about 13. If we look at our heart numbers right away, could we simplify those?
Yes.
Yes. What could they all be divided by?
2.
A 2. So if you want to simplify them right away, you can. However, can our radical be simplified? Yes. So I would simplify the radical first, because if you don't, you're going to simplify your heart numbers, and then at the end, after you simplify your radical, you're going to have to recheck your heart numbers. So it's best if we simplify the radical first, and then just save our heart numbers for the very end. Either way, you could still get to the correct answer. So if you forget, it's probably okay as long as you do your work carefully and recheck. But it's best if we simplify radicals first. What are we breaking 50 into? 5 and 10. 10 breaks into 5 and 2, or 2 and 5. My pair is the 5s. The lonely guy is the 2. So I go back over here to rewrite this. I've got a 30 plus 4. And then I'm simplifying the square root of 50. So what's coming outside? The 5. What symbol do you think I want to put right here? Multiplication. The 4 was already outside that radical, so it's going to get multiplied to whatever we bring outside. Who's staying inside? 2's got no friends. My denominator is still 100. Okay, so on our next step to simplify this, what am I doing? 4 times 5 is 20. Create myself a little more room here. 20 root 2 all over 100. So now when we make our heart numbers, we know that we're at the very end of the problem because we already simplified our radical. What could I simplify those by? Factor of 10. 30 divided by 10. 20 divided by 10. Stuck with the square root 2, all divided by 10. Questions about that step? Okay, now here's one thing I want to caution you about that we haven't really worried about just yet. Some people get excited and they see this 2 outside the radical and this 10 down here, and they want to reduce those. But why can't we? Because of that 3. When we do these, we've got to look at all 3 of those heart numbers, as we've been calling them. And if not all 3 of them are divisible by the same thing, we have to leave it alone. Questions? Concerns? Got one more? Okay, why don't you... let's just do it together. Some of you probably have already started on it, and that's wonderful. So what do we want to do first? Simplify the radical. Our heart numbers right now could be simplified, but then we might have to do it again later. So it's best if we just simplify the radical first. If we simplify the square root of 16, some people might notice something special about it. 4 and 4, this is a perfect square number. Got a 4 and a 4 right away. We don't have to keep going if we get a pair right off the bat. Just stop and circle them. So when I go to rewrite this, got a -6 plus 4. Remember, when we simplify a radical, whatever was already out front gets multiplied to what we are bringing out front, which is a 4. Do I need to write a radical? No, because there's nothing to put under it anyway. So we just won't even write it. Divided by 40. This is a special type of situation where we don't have a radical at all. So this is going to get simplified all the way down to just being a fraction. So we kind of have to revert to our order of operations. So if I'm looking in my numerator, what should I be doing first? 4 times 4 is 16. Now, if you want to, you could treat these like heart numbers and simplify them. But because this no longer has a radical trapping it, it can get combined with what's in front. The only reason we never did that before was because the radical was sticking to it, not allowing it to be combined. But the radical's gone, so negative 6 plus 16 is 10 over 40. And then we just simplify that like a fraction from middle school. We get 1/4. Questions, concerns, Keon? We what? Add what? Yep, the negative 6 and 16 got added. We didn't do that before because we always had a radical on the end of it, but this one's radical went away.
Yeah,